Let's go through LeetCode 1548, the most similar path in a graph. So it gives us n cities in the m bi-directional roads. So this is the roads. In the roads, they have two directions. That is AI city is connected with BI. Each city has a name, so it gives us a name array which represent the cities. In the starting at any city, you can reach any city y, where y doesn't equal to x. So you will be given a string array target path. So we need to find a path which should be the same length of the target path, but with minimal added distance to the target path. So let's look at the example, right? And we have 5 nodes, and the roads is, for example, 0 and 2, they are connected. 0, 3 are connected. 1, 2, 1, 3, and 1, 4, 2, 4, right? The names and the target path, we'll see there is DB target path H. Here, the name and the target path, they all exist in this example. So we find a path with 0 goes to 2 and go to 4 and go back to 2. And in that case, we have added distance to be 1, right? So only DXB is different. For a second example, we'll see we have target path ABC. You see, this is not target path. This one is not exist in our name. So that is actual city, right? So the difficult part for this one is that this target path may not exist in this kind of A, right? It may be something else. And also, let's look at the third one. The other difficulty part is that let's say this kind of ATR can be 0 and 3, right? Can be used as 0 and 3. So that means this kind of names we'll see n, right? 1 to n goes to names that is 1 to 1, right? That is one city may goes to one name, has one name, right? But for one name, it may have multiple cities, right? So this may not be one-to-one matching. For this kind of question, we want to find the minimal added distance. So intuitively, we're thinking about is that if we find a path, for example, which has a minimal added distance, then we trying to go back from this path, right? So find the minimal path that there is one way that is possibly we're thinking about BFS or a darkest trip, right? why we're thinking about a BFS or Dijkstra is that because we're using the road, we can construct the graph. We have graph, and for that one, every city we are able to go to its neighbors, so we can construct those kind of neighbors, right? But the thing is that here we need some kind of way to represent for the distance. That means for us, if we arrived at a city, what is the current added distance, right? And also we need to pass in the current added distance to the every node we put into the cube, right? So the added distance is that we have a target path, right? So that we just need to compare with we're passing current added distance. And if we are in a city I, and at index, for example, this is J to J. Let's say the target path has a length N L, right? And it's index J. And if current city doesn't equals the target path the city, right? So we'll say this kind of added distance, we have a one extra, right? So what we do is that we trying to see for the next, for current city, we want find we have map, right? We find its next possible road. So we are going to check its next neighbor, its neighbors, and for its neighbors, that our index J will become J plus 1 in our target path, right? So if its neighbor, the J plus 1 has the same city in the target path, right? So that means that the added distance is not increased. Otherwise, the added distance will increase by 1, right? So we can have we look at its neighbors, trying to see whether the neighbors at a J index J plus 1 whether the next city at a J plus 1 index, whether the added distance is decreased, right? If we decrease, that is then we need to include, right? So we can have a distance array. We just compare, right? So in the end, we have the index at L minus 1, right? L minus 1, and we have the city we reached at the last, right? So the things that we need to go back. In this way, we can get the most shortest edge distance of all of the paths, but we need to from our shortest edge distance of our path to construct the path we visited, right? So we need another array, possibly called, how can we use from the last city we reached to construct the path? We can use another two-dimensional array, right? So that we call parent. So in the end, we'll see if it reached this kind of last city, we find the minimal added distance. Then we retrieve back to its parents, and then for its parents, right? So we use parents array, And for example, the every j we goes back to j minus 1, right? And in that case, we compose back the path. So okay, so let's begin to write code for this, right? We need to have a map, right? We from the roads we compose a map. We call integer list of integer map equals new hash map. Okay. And what we do is for 8 road in roads, we're going to have compose because these two direction map completely absent. Road 0 goes to new array list at road 1, right? And also road 1 at 0, right? Let's have int l equals target because I just noticed it has m here. You see that it is m rows, right? So the m represents it is actually not the same as target path, right? So let's use the target path dot length here. So we are going to have a distance array equals new int and l. So what does this one mean? Let's say distance I j will represent the minimal added distance to reach the target path j, right, position when current city is I. So this is our distance array, right? So that means in our the j's index in target path, and our current city is I. What is the minimal distance we have, right? And we also need a parent because when we finish the Dijkstra and in the end, right, we find a smallest distance path distance value. We need to use parents to construct those paths, right? So these parents will represent parent I, j, will represent the previous city in optimal path when current city is I, and index index of target path is j, right? So is in a position j at, okay. That's right. So this is the two arrays we need. And let's set the distance array to be always the final static int I equals integer dot max value ratio to, right? So let's have arrays the distance. Let's do this for every d, right? For int d distance arrays the d. Okay. And let's set these parents to be -1 for p parent arrays here p -1. And we need to have a priority queue for Dexter. So we are going to pass in integer array PQ equals new priority queue. So we're going to have a b. So for this kind of index, what we this kind of interarray, we put three things, right? Array, this kind of array. Index 0 will be current city, right? Current city. And the index 1 will be the J index in target path, right? Yes. And 2 will be current to this J, right? To this kind of what is the current edit path, right? Edit current edit distance. So it will be we firstly compare if A2 equals B2, right? So then we're going to have compare integer compare also the A1 B1, right? Actually, we just need to have the edit distance because possibly we can have a reverse, right? B1 because it's almost the end. So that will be optimal. Then we're going to have compare A2, right? B2. So that means in the target path, if we go have a longer path which have edit distance smaller, right? That is our. So if it's almost reaching to the end, that means, for example, there are 10 cities. We almost goes to 9, and our current is 80 past, for example, 5, right? That will be, of course, optimal. Then we already visited 7 cities, and the current 80 past is, for example, 20, right? So, but the thing is that we compare edit distance first, then compare how many cities we visited. So the less, this one will be reversed, right? So and the edit distance we compare in a increasing order, right? So what we do is that for int I equals 0, I smaller than n, I plus plus. We are going to have p int edit current edit distance equals target. The first one is the first one we can choose the from city 0 to city n, right? So we look at the target path 0 and to see if it equals these names, right? If it equals the first one, edit distance is 0, otherwise it is 1, right? So distance, so at I 0 will be D, right? And we have PQ should be offered new int I 0 D. So this is we put initially we can start at any city, right? So what we do is that while this queue is not empty, queue is not empty, PQ. Then we are going to have current equals PQ dot port. And we're going to have current city, right? Current city equals current 0 and current index. That is the current index in the target path, right? That is the current 1. And current edit distance, right? D, okay. Yes. Edit distance. This, okay, equals current 2. So the things that if our current index equals m minus l minus 1, right? That means we finished the path, right? Then we should continue. We should not include anymore, right? Because the Dijkstra, we put the edit distance as a first comparator, right? Not the city as a first one. So means it's possible some weighted later, some that still have index is smaller, right? So then what we do is that for int next in map get all default. Well, let's say if let's compare whether it exists, right? If map contains key current city, then what we do is that for next for int next in map get city, right? So so for next, right? We whether we need added distance is that we should have this one on target as current index plus 1, right? Trying to compare it with whether it equals names of the next, right? If it equals, then for the next we'll not add edit distance. Otherwise, we'll add 1, right? Because it's different. Then we'll say if distance next current index plus 1 is greater than current edit distance, right? Current distance plus D. That means we find a shorter distance, right? Then we'll have distance Next, current index plus 1 equals current this plus D. And we're going to have because we in the end we need to compose the path again, right? So let's set the parent here. Parent next, and the current index plus 1 equals current city. And we're going to have PQ dot offer new int next current index plus 1 and current this plus D, right? So this is the texture. So in the end, what we need to do is that we need to find the minimal distance, because when we look at this kind of distance array, right? So we need to look to compare the distance L minus 1, right? For this kind of I from 0 to n, and find that means we are current at index the city I. What is the minimal at this distance? Then we return back to construct the path, right? So what we do is that we have, for example, int minimal equals INF, right? And let's set n equals -1, right? So because we want to find what is the end row, end city, right? For int I equals 0, I smaller than n plus, we're going to have if distance I L minus 1, right? If this one is smaller than minimum, then we have minimal equals distance I L minus 1, and we'll have n equals I, right? So now we find the end city which have the minimal at this distance. We can use the parent this array to construct the path, right? So list integer result equals new array list, and for int I equals m minus 1, I greater equal to 0, I minus minus, right? So what we do is that we have result add n, and we'll have n equals the parent, right? Parent and I. And this kind of path is reversed, right? So we should have collections reverse result and return result. And this is the L, right? Doing like this, if we have n, there are n cities, right? N cities and m rows, right? For this one, this is m multiplied by so this is an O, for example, m rows, m operations, right? And but we have a path, for example, this is L, right? So I think those kind of cities are going to so this, for example, we have we are going to iterate the roads, right? So if there are m roads, and let's think in the there L pass, right? So we should have L in our time complexity, and we also iterate the kind of roads, right? That is the age. And what we need is that every operation we use a priority queue, right? So that is I think m multiplied by L and log, right? Because this depends on how many times our interarray being included, right? And there is a log L multiplied by m, right? M those kind of m multiplied by L log m log L. So the space, space will be also depend on the n and m, right? So that is linear. Let's write a Python code for this as well, right? The Python code. So let's have INF equals float INF, and we are going to have graph equals this one I for I in range n. Okay. Range n. Let me see. Yeah. Let's have compose every list for a city, right? So that for the Java, right, we just use a compute if absent, right? But we can compose for every city. So what we have for road in roads, we're going to have graph road 0 append road 1, and also we can append the this one append the road 0. Then what we do is that let's have L equals length target path, and we're going to have distance equals INF for multiple by m, right? For this one in range A, and parent equals -1 multiplied by m for underscore in range n. So this is the distance array. Distance is edit distance, right? When we count cities I and index j in the target path, and also parent will be current city I index j. What is parent? So where does this one coming from? PQ equals priority queue, right? So what we do is for I in range n. So we'll have D equals 0. If target has 0 equals names I else 1, right? So we are going to have distance I 0 equals D. And we have heap Q, heap push, heap Q, heap Q, heap push, PQ, and D I 0, right? So we want the distance to be smallest, and let's have minus I, right? Minus I, because we want to close to the targets. So then we are going to have while PQ. So we're going to have current disk, right? And the current CD and the current index equals with Q dot heap pop PQ, right? So we'll say if current index equals L minus 1, right? Then what we need to continue because we already end. Otherwise, let's say for next city in browse, get if if we can also like get a default, right? Get current city is empty, right? So we also have this kind of logic, right? D equals if current index plus 1, current index plus 1 equals next city, right? So we need to compare the distance array. If distance next city current index plus 1 is greater than current distance plus D, then we're going to update, right? And also we need to have set the parent next city current index plus 1 equals current city. And we also need to heap dot push heap Q, right? Heap Q dot heap Q dot heap Q dot heap push PQ. Um, so that is this one. And what's So this is city, right? And this is we should have minus here, right? And um current index possibly, and the city is next to the city. So in the end, right, we should have the mean list equals I in F, right? So what we do is that also and the city equals -1. We need to find from the distance area. So in I in range, and so let's say if distance I -1, right, is smaller than mean distance, then we'll have mean distance equals distance I -1. And we are going to have and C2 equals I. Then we need to compose our result, right? Result equals this. And what do we go for? I in range m-1 -1 -1. We just result append and city. And we use a parent array to update and city equals parent in the city. I. Then we have result. We need to reverse, right? Result, reverse, and return result. Mm, not sure whether Python should can write like this, right? Um, let's put this one as positive. This will not affect because the distance we compare the distance and we are always go through the whole path, right? So invalid. Um, if current this one So also we can still put this one as minus 920. CD. M is not defined. So this is a error. Range. So if current index equals I minus one, we should not should already continue. Then for next city, list auto range. Next city. If names equals D equals so so possibly we cannot put a negative here. M is not defined. In range 30, 8, error. This not. Next. Should equals names. Next city, else one. So what's the problem? Minus one. PQ. Distance. You push. It's from edit distance. J-index. J-index. Yeah. This is reversed, right? If we put I here, then this will be current CV. And let's put this map in the back. Current CV and yeah. So okay. Now since this index, we can, I forget how to put the negative here, but I will check a little bit later first. But if we don't, but the thing is it will sort by distance, edit distance, right? And optimal so-called will set reverse as index. But if it doesn't, for this order, if we don't order it, we'll just get the whole solution, right? Every distance will calculate. We only terminate when the current index is L-1, so we'll also always get a result. So this is the Python code. Okay.